Losing a natural tooth triggers a biological crisis beneath the gum line. The intricate network of fibrous connections between the root and jawbone is severed. During normal chewing, a healthy root provides constant microscopic stimulation to the alveolar bone holding it in place. Without that root, the body receives a biological signal that the bone is no longer required, and it begins to dissolve and reabsorb the tissue. This chart tracks bone resorption. You can lose 25% volume within 1 year. This deficit destabilizes adjacent teeth, causing them to drift and loosen. Ultimately, this bone atrophy collapses the lower third of the face. Delaying treatment transforms a single extraction into a spreading structural disease that can eventually require highly invasive reconstructive surgeries. For generations, the only countermeasures were removable acrylic dentures or tooth-supported bridges. These methods address the visual gap while allowing underlying bone destruction to continue. To halt bone loss, dentistry relies on osseointegration, the direct, functional connection between living human bone and the surface of a biocompatible titanium root replacement. But the global market is saturated with generic clones, produced with minimal clinical oversight. While a cheap implant typically features a relatively smooth surface, premium manufacturers engineer the topography of their implants at the nanometer level. Through patented processes, top-tier brands create surfaces covered in microscopic craters and peaks. These advanced textures are highly osteoconductive, attracting blood proteins and bone cells to accelerate the healing timeline from 6 months down to a few weeks. The specific material purity and surface texture embedded into your jaw dictates your long-term resistance to bacterial infection and overall implant survival. In Muscat's elite healthcare sector, guaranteeing those long-term results requires an environment guided by advanced digital dentistry. Executing these complex rehabilitations freehand, relying only on flat, two-dimensional panoramic X-rays, carries significant risk. This shows the output of a 3D CBCT scanner. Specialists map your bone density, sinus cavities, and vital facial nerves. Using CAD/CAM software, the surgeon virtually aligns the implant's trajectory with your bite force to fabricate a custom surgical guide. Purchasing a premium piece of titanium is the first step, but its success depends on using a physical surgical guide to ensure placement matches the digital plan with sub-millimeter precision. We can map specific anatomical deficits to the technology designed to solve them. For patients who have suffered severe bone resorption, the jaw is often too thin to support standard titanium without painful bone block grafting. The Straumann system engineered Roxolid for exactly this profile. It is a high-performance alloy composed of 85% titanium and 15% zirconium. That specific formulation increases the tensile strength of the metal. Surgeons can utilize narrower implants in thin spaces without sacrificing load-bearing capacity. Straumann pairs this with an SL active surface, which is highly hydrophilic. The moment it makes contact with the jaw, it acts like a biological sponge, drawing blood and osteogenic cells into its micropores. By matching a narrow ridge to this high-strength alloy, patients can bypass complex bone grafts and months of delayed healing. For patients requiring the total rehabilitation of an upper or lower jaw in a single day, Nobel Biocare provides the clinical standard. This model illustrates their all-on-4 treatment concept, which anchors a complete dental prosthesis using only 4 strategically placed implants. By tilting the posterior implants up to 45 degrees, the surgeon secures them into the dense anterior bone, avoiding hazards like the sinus cavities. Nobel utilizes an aggressively threaded implant design that compresses and condenses the surrounding tissue as it is driven into the bone. This high primary stability enables a patient to have failing teeth extracted and a fixed temporary smile attached in the same surgical appointment. Patients with poorly controlled diabetes, those with severe osteoporosis, or a history of heavy smoking face higher risks because their bodies struggle to regenerate bone. Zimmer Biomet addresses this with their trabecular metal technology, marking a radical departure from the conventional solid titanium cylinder. They engineer the midsection of the implant from tantalum, creating a porous, three-dimensional web that mimics the 80% porosity of human spongy bone. This structural mimicry triggers osseoincorporation. Living bone tissue and nerve endings grow directly through the porous web, creating a three-dimensional biological interlock. This aggressive deep tissue vascularization provides a reliable mechanical anchor for immune-compromised patients. For health-conscious patients focused on preventing bone resorption at the neck of the implant over decades, Dentsply Sirona offers the AstraTech system. Their design centers on a conical seal, a deeply tapered, mathematically tight connection that creates a hermetic seal and stops microscopic flexing during chewing. This tight seal prevents oral bacteria from being pumped downward from the mouth into the sterile bone layer. Conversely, when replacing visible front teeth, the concern shifts to the soft tissue. If the gums recede, a dark metallic line becomes visible, destroying the symmetry of the smile. This cross-section shows BioHorizons laser lock technology. The titanium collar is etched with laser-machined microchannels. The connective tissue fibers of the gums physically and biologically attach themselves directly into these grooves. Restorative permanence requires manipulating soft gum tissue to form a physical seal against bacteria, shielding the underlying bone from long-term infection. Once the premium implant fuses with your jaw, the responsibility for its survival shifts from the surgeon to you. Artificial teeth cannot decay, but the surrounding tissue is susceptible to peri-implantitis, an aggressive inflammatory disease caused by the accumulation of plaque biofilm at the base of the implant. A manual toothbrush is inadequate for an implant patient. You must use an oral irrigator every night to flush out the debris hiding in deep gum pockets. You must also recognize the impact of nicotine. It constricts your blood vessels, starving your jawbone of vital oxygen required to sustain the implant. Investing in elite biomaterials is a futile endeavor without enforcing absolute smoking cessation and impeccable interdental hygiene. Purchasing an implant based on the lowest upfront cost routinely results in expensive surgical revisions and replacements. This evaluation matrix shows that clinical success relies on aligning proprietary engineering directly to your unique anatomical deficits. Your next step is to secure a diagnostic evaluation. Seek out a specialized implantology team in Muscat that utilizes 3D digital planning to map your specific physiology. By combining digital mapping with the correct elite implant system, tooth loss becomes a fully solvable mechanical equation.